particle moves in a straight line with acceleration equal to minus the square of its velocity. If the initial velocity is 2 meters per second, calculate the distance travelled in 3 seconds later. Okay, let's start off with A. Its acceleration equal to minus the square root, so just A equals minus v squared. Okay. Next thing, you have a choice. You have a choice between dv dt and x dv dx. So choice A and choice B. Which choice do you make and why?
dv dt. It says
both. Yeah, we're going to use both. Yeah.
Where'd you get x from?
Distance. They use s. So if you imagine my solution is going to look like this, and their solution is s's, my solution is x's. There has to be distance.
It's v. Yeah, it's v dv. Because you get dx dt, and that's v.
What?
Is it v dv dx? Yeah. It's not v.
Oh, sorry. Jeez. V dv dx for the other option. Whew. That would have been a rabbit hole to go down. Thank you. Sorry, it's v dv dx is option B. Okay. Yeah. So look, I'd be going after the VDT first by the reading the question. Would you guys as well? Yeah. I think we end up going after both of them, but to be honest, I'd be feeling the VDT first. And what I'd have here is v to minus 2 dv. When you bring the v squared underneath, negative power, then minus dt. We're going to put in some limits. Initial velocity is 2, so what's that mean? 2 and 0. And then we can get a v and t. Is that okay with you guys? Alright. Integrate that. And we get add 1 onto the power, differentiate by the new power. V minus 1, or sorry, divide by new power. And then okay, minus t, minus 1 over v, minus a half, which is plus a half. So I'm at sort of at this stage here. And yeah, bring the t to the left and the 1 over v to the right. So we're going to get a. Which letter would you isolate? It's hard to tell, isn't it?
You should try to isolate B so you could match them up with the two.
Yeah. I'd park it there for a second and I'd just like, okay, haven't really developed this as much as I would have liked. So I'm going to go the other route, the v to vdx. Remember, we didn't take it at the start. So I'd honestly, in test, I'd be just like, I'm just going to pause it here. I'm going to see what other information unfolds, and then I'll decide what the route to go down in a few minutes. Right? I currently don't know. If I didn't have that market scheme looking at me in the face, I wouldn't know. Okay? So I'm just going to go back to the beginning. Is that okay with you guys? Everybody alright with what's on the board so far? We all good? Alright, we go back to the very beginning. And this time we're going to use v to vdx, okay? The very beginning. So when the phi squared goes underneath, it's phi divided by phi squared, or just cancel it off outright. So it's going to be 1 over v dv equals minus dx. We'll put in our limits. What do we reckon? Its initial velocity was what, guys? 2. It means it travelled no distance at that point in time. This is x, and this one here is v. Integrate, and what do we get? ln. We should be getting ln v from v minus 2 minus x from x to 0 ln v minus ln 2 equals minus x, and now we're left with this ln v over 2 equals minus x. Alright, would everybody agree we're looking at our two equations here? Different colour. Everybody see the two equations we're looking at? Okay, we reread our data at the start of the question and we go, it wants the x value when the t value is 3. Everybody got that? The x value when the t value is 3. No bother. I'm going to find the v value. I'm going to find the v value when the t value is 3. Is that alright with you guys? You're going to be really lazy about it as well. What's a half plus 3? 3.5? 7 over 2? Everybody cool with that? So 7 over 2. Turn 7 over 2 upside down. What's v? Excellent. Now what am I going to do with the ln here? It's going to be ln. What am I going to replace v with? Yep, because that's its velocity at that time. Okay? And now it's become extremely obvious what I need to do. I suppose it says ln 7 in the answer, so I suppose I should show how you get that. What's 2 7s divided by 2? ln 1/7, yeah? And ln 1/7 is ln 1 minus ln 7. ln 1 is 0. So therefore x equals, and you're done. Okay? Any questions about it, or did anybody have a different route they were thinking about going down, or anything you want to ask about? Particle moves in a straight line, undergoes a deceleration of 0.06 phi cubed, where phi is the speed. If the initial speed of the particle is 15 meters per second, find its speed when it has travelled a distance of 10. Velocity, distance. Oh, sorry. Phi is 15 when x is 0. We're looking for the phi value when x is 10. Is that okay? That to me means phi dv dx all day long. You okay with this one? What do we do next? Phi squared underneath. So 1 over phi squared dv equals 0.06 dx, okay? Then what? What do we say? Phi and 15, 0 and 10. Okay. What happens if you integrate phi minus 2? Yeah, which we all know from earlier is minus 1 over. We did it earlier. 1 over 15 minus 0.6. 8 minus 8 over 15. Yeah. So give me a sec. What did I do wrong there?
Is V increasing or meant to be increasing or decreasing?
Hmm?
Is V meant to be increasing or decreasing?
Look at it now. Something's up. Oh, there should be a minus here. What happened to my minus from earlier? There it is, lads. So I got negative speed. I knew something was up. Keyword, deceleration. Minus, minus. Quick fix. Minus, minus. Plus. And now you're back in business. So, yeah, that can happen. 2 over 3. And I love doing the turn it upside down thing. So then phi equals 3 over 2. We all good? This is a very easy question. We'll find something more difficult in a second. Find the time taken for its speed to reduce from 15 to 12. Time taken, right? Time taken to do that. Alright, let's think about that. 15 to 12 time. Okay. The VDT. What did we say earlier? 0.06 phi cubed, yeah? Yep. Start the clock at what, lads? Start the clock at 0 for 12. Because it just wants the time in between 0, 12 and 15, okay? Or is it 15 to 12? Deceleration. Sorry, I'm wrong. Start the clock at 15. End the clock at 12.
The initial speed before it was 15, so.
Oh, is it? Even if it wasn't, still works. Okay. Now, 1 over phi cubed to v minus 0.06 to t. Smashy smash, right. V minus 3. Which one goes where, guys? 0 and?
15.
Yeah. 12 and? T. Alright, this is very bog standard question at this rate. V minus t over minus 2. 12 and 15.06 t from t to 0. And lo and behold, your calculator is going to do all the work. It's going to be 12 to the power minus 2 all over minus 2. Minus 15 to the minus 2 all over minus 2. Equals minus 0.06 t. If you can give me that, what's in that bracket, that'd be great.
Yeah,
Hoping negative anyway. Or positive.
minus 1 over 800.
Brilliant. And divide that minus 1 over 800 by 0.06.
1 over 48.
Happy days. Yep, 1 over 48 all day long. Happy enough with that one? Alright. You want to try find one